Welcome to the first lecture of probability, the branch of mathematics. Probability is the branch of mathematics where many predictions, a correct prediction, if we do, then it will be useful for the society. It is useful for the nation if we do the correct prediction. So, the probability theory is such a beautiful topic where we can predict the most important things which happens. Suppose we our predictions are wrong, suppose definitely there is a very big loss for the nation. So many, like machine, it may be the machine learning, it may be the artificial intelligence, or it may be any scientific experiments, or it may be the launching of a satellite, whatever. If we do the correct prediction, then it is a great benefit for the nation. So, when we do this probability, we have to understand what are the fundamentals of probability. So, this chapter is being introduced for engineering students. So, let us come to the introduction. As you know, all of you, about probability means the chance of occurrence, or the whether the event is going to happen or not happen. All these are the definitions of the probability. So I don't want to waste the time by giving only the explaining about the meaning of the probability. Instead, I wanted to give in this lecture about what do you mean by the probability, and where you use this probability, and what are different concepts of like sample space, what are the mutually exclusive events, all these, and what is the difference between the independent event and mutually exclusive events. Most of the students are asking doubts about what is the difference between mutually exclusive and independent events. So for all these questions I want to give the answer in my lecture. So let us now start with the topic. So first of all, when we say about the scientific experiments are of two types. One is the deterministic and the other is the non-deterministic. In the deterministic experiments, definitely the outcome of the experiment is sure. That means certainly this should happen. For example, if I say what is 2 plus 3, the outcome is sure, is definitely it is 5, it is sure, that is the sure outcome, right? Similarly, if you take water and the hydrogen and oxygen, if we add, that there is an outcome which is surely it happens. So these are all called as a deterministic experiments, whereas the non-deterministic or the random or the probabilistic, or sometimes we call it as stochastic also. These stochastic, all these are nothing but the experiments where the outcome is unknown. So that means it may be that in our life many things are uncertain, right? What is going to happen tomorrow, we don't know. But if we are able to predict what is going to happen by taking the previous analysis, that means in the past a couple of days what is happening, or a couple of years what is happening, depending upon the particular event. If you take that what is happening in the previous cases, then we can analyze and we can give a particular decision about the outcome. So whether it is going to happen or not happen. So that happening, suppose if it rains tomorrow, 90% probability is there of getting a rain tomorrow, means definitely we say that possibility of getting rain is more. At the same time, the temperature is more in the hot summer season. The temperature is more. So tomorrow, what happens? Or when the people go for fishing, then they can understand what is the situation near the oceans. So near the seas, what happens? All these, if you do the prediction suppose, then if it is the perfect prediction, suppose, then definitely we can be alert and solve the situations. So these are all non-deterministic. So to understand these non-deterministic or probabilistic, whatever, generally what we take is what is going to happen, which we don't know, means the immediate examples what we take in general is we tossing of a coin. Because when you toss a coin, we don't know whether we are able to get a head or a tail, right? So the occurrence of the head or tail is not a sure event. So that is a tossing of a coin. Or you can take the rolling of a die. So even when you roll a die, definitely I am not sure that I will get 6. So that is also an undeterministic or non-deterministic or the random experiments. Or you can say the weather forecast like that. These are all the non-deterministic experiments. So now to understand the probability in a deep version, you have to understand the minimum concepts. That is, number one is the sample space. What is meant by the sample space? The sample space is nothing but whatever the outcomes are present in the experiment, the possible outcomes are there of an experiment, suppose, then we say that it is called as the sample space. So the set of all possible outcomes, the set of all possible outcomes, is called as the sample space, So that means if our experiment is tossing of a coin, then what is the sample space? We generally denote the sample space by yes. If our experiment is tossing of a coin, then either tail or head. This is what the sample space. If our experiment is the rolling of a die, suppose, then we may get 1, 2, 3, 4, 5 and 6. These are the possible outcomes. The possible outcomes in the sample space of the experiment, of the random experiment, I can say, as the rolling of a die. Suppose, if again there is a random experiment, we can say that when you write the examination, what are the possible outcomes? Either it is pass or it is a fail, correct? So these are the possible outcomes when you write the examination. And when you are tomorrow, when you are attending the class or not, or tomorrow I'm able to make a lecture like this or not. So these are all the possible outcomes, correct? So this is called as a sample space. I hope you could understand. And now we say about the size of the sample space. What is meant by the size of the sample space means the number of elements which are present in the sample space is called as the sample size of the sample space, or we can also say that it is sample size. Generally we denote it by n. So n of the sample space of tossing of a coin, if you take, that is 2. And n of yes, when the experiment is rolling of a die, it is 6. N of yes, when the experiment is writing the examination, that is 2. So these are what the size of the sample space is, the next definition. And then coming to the next important point is the events. Suppose I want to find out what is meant by the event. Event is nothing but what the subset of the sample space. Now, for example, in the experiment of rolling a die, I want the event E. The event is nothing but is the subset of the sample space. Is the subset of the sample space. Is the subset of the sample space. So what do you mean by the event now in the example? Suppose the rolling of a die, if you take, I want the event of getting the even numbers. Then this is the event 2, 4, 6 and this is the event which is the subset of the sample space. Suppose I want another event, let me call this as E1, and I want another event of getting only the odd numbers of in the rolling of a die. So now the odd numbers are 1, 3 and 5, like this. So these are what are called as the events. That means the subset of the sample space. Now let us come to the next important point about the mutually exclusive events. Most of the students will get doubt about what is the mutually exclusive events. The name itself here says that mutually exclusive it is. What do you mean by this? That means if the two events, suppose A and B, the occurrence of one event, it prevents the occurrence of the other. That means if the two events exist, suppose the two events A and B are said to be mutually exclusive or mutually exclusive events, mutually exclusive events, if the occurrence of one, if the occurrence of one event, occurrence of one event prevents the occurrence of the other. What is meant by this? Prevents, remember this, prevents the occurrence of the other. So that means what it is. So let us take the rolling of a die, occurrence of the other. Rolling of a die, or you can take the tossing of a coin also. When you get, suppose, when you toss a coin, head is displayed first, or it may be displayed as tail. So can we say that when we toss a coin, both head and tail we get? That means what? Head is preventing the occurrence of the event, head is preventing the occurrence of getting the tail. Similarly, occurrence of the tail prevents the occurrence of the head. So this is the mutually exclusive events in the experiment of tossing of a coin. Similarly, if you take the rolling of a die, suppose, definitely if I take 1 and then 2 and then 3, 4, 5, 6, all of them are mutually exclusive. That means when I am getting 1 means it is preventing the other to happen. When I get 2 means it is preventing the other to happen. That means definitely both 1 and 2 I cannot get, or both the events, or three of the events doesn't happen. Correct? So these are called as a mutually exclusive events. So in real time, suppose I give you one small example of you are in the class. You are attending the class now at present. You are attending the class at let us say 9 a.m. and attending the movie at the same time 9 a.m. Is it possible? You are attending the movie at the same time 9 a.m. That means you are going to a theater and then going to the movie and then watching the movie. Both of them are two mutually exclusive events. I hope you could understand now. This cannot happen at the same time, right? One is when you are in the class means definitely you are preventing to go to movie. Or if you are in the movie means definitely you are preventing to go to the class. These two are the mutually exclusive events, you can say. So both of them will not happen. So that's why when you say in the set theory generally, next I will explain you about the set theory concepts also. So these are the two disjoint events. Definitely both of them will not happen, will not occur at a time. Understood? Then we say that these are the mutually exclusive events. Now let us go to the next important aspect of independent events. What is meant by the independent events? Now the events A and B are said to be independent if the occurrence of one event doesn't affect the occurrence or doesn't influence the occurrence of the other event. Suppose if A and B, if the event A doesn't affect or doesn't influence the occurrence of the event B, suppose. Occurrence of the event B, suppose. Then we say that they are the two independent events. So in this also, I take an example of, now A is an event, let us say that I wanted a tail, occurrence of the tail, in tossing of a coin. That is the event A. Now let us take the event B as the occurrence of passing the exam. Occurrence of passing the exam. Is there any link between these two? Getting a tail in tossing a coin is one event. Passing the exam is another event. So both of them are two independent. Correct? One more thing. Are they? So that means one doesn't affect the other one. Correct? So these two events are independent events. That means here, now many of the students ask me, what is the difference between mutually exclusive and independent events? Now the question is there, now as I told you that when I say that mutually exclusive events here, the intersection, that means both of them will not happen at a time. That is what mutually exclusive means, I said. Correct? Now let us go to the independent events concept. Can I get both the events happen at a time? Can we say the two events can happen at a time? Yes, of course, right? When I toss a coin, definitely I may get a tail. At the same time, I can write the examination and I will pass. Or occurrence of attending the examination or not attending the examination, you can say. So that is another thing. Or I will say one more event. Let us say B2. Another event is occurrence of getting 3 when you in a die. When you roll a die, occurrence of getting a 3, suppose. Then that is also definitely when you do these experiments, when you are doing two different experiments you are doing, this event is not affecting the other event. Suppose if I say that if I get a tail, then definitely I will get 3 in die. We cannot say that, right? So these are the two. These are called as the independent events. But at the same time, they are not like how I have drawn in the mutually exclusive events. The events A and the events B1, B2, there may be common because they may happen at a time, correct? So it doesn't affect the other, but it doesn't mean that both of them are disjoint. I hope it is clear, I think so. Mutually exclusive means one prevents the other to happen. Independent events means one doesn't influence the other to happen. So it doesn't prevent other to happen, okay? So it doesn't influence the other to happen. This is called as the independent events. So now, when you say that independent event, then we will come to the next multiplication theorem and all. At that time, you should understand what is meant by the independent events. As I said, the common area of A and B1, B2, all these are not empty sets. Whereas if you take in the mutually exclusive events, these there is no common portion for mutually exclusive events. Please register that in your brains. So this is independent event and that is the mutually exclusive events. And now coming to the another point is the equally likely events. Equally likely events. What is meant by equally likely? Means whatever the possibilities we are getting in the sample space, the possible outcomes, all of them are getting the same probability, suppose. That means equally likely means each event has the same chance. Every event or each event of the sample space. Each event of the sample space has equal chance. Has equal chance, suppose, then as the other events. Equal chance as the other events. So all of them will have the equal probability, suppose, then they are equally likely. That for example, as again in the tossing of a coin, the possible outcomes are tail and head, right? So the chance of getting a tail, that means the probability of getting a tail is half at the same time when it is unbiased, okay? And the probability of getting a head is also 1/2, okay? And then if the sample space, suppose, is 1, 2, 3, 4, 5, 6. Now, in this, what is the probability of getting 1? That 1 is 1/6, which is same as probability of getting 2, which is same as probability of getting 3, and so on, probability of getting 6. The chance of getting 1, 2, 3, and so on is totally 1/6. So, this is what meant by the events which are the equally likely events. So the events 1, 2, 3, 4 and all, and the tail and head are, these are all the equally likely events. So this is what about the my agenda of this lecture is to give the explanation about mutually exclusive events, independent events, and then equally likely events. Once it is done, we have to understand about the set theoretical concepts and interpretations now. What is meant by union, what is meant by intersection, all these we should know in this to understand the probability. So what is the set theory? Some small concepts of set theory let us now take. Suppose I have two sets now. Let us consider A and B or any two sets. Suppose I draw the figure here. I have any two sets. Suppose let A and B or any two sets. Now let us have that A and B or the two sets. Now what do you mean by A union B means? Now here we cannot, here what we do is here we just, I'll just take it. Let us draw the figure here. A and B are the two sets. Now I wanted to see the union of both the sets, suppose. That means I will take the union of both the sets. A union B means the whole portion which is being covered in both the sets. This is given by A union B. This is called as A union B. Okay. That means the portion which is covered in A as well as in B. Let me have, suppose A is equal to the elements 1, 2, 3, 4. Now if you write like this also, you will understand more easily. So 3, 4, 5 and 6, let us say. Now then, what is A union B? A union B consists of all the elements which are there in this. That means 1, 2, 3, 4 and 5 and 6. So the elements which are in A union B means they are either in A or in B. So this is what the meaning of that. So we can immediately, you can understand that the elements which are there in A or B is nothing but A union B. Now let us go to the another operation between the set structures. Let us see now. Now it is A and B, and let us draw the figure as A intersection B. Now this is the portion which is common in A and A intersection B. So that means A intersection B is this, is given by, this is A union B, and this whole thing, okay, I mean this whole thing is A union B, and this is A intersection B. Now what is A intersection B in the above example? According to this, we are able to see that there is 3 common, which is whichever is common, those are the points which are coming in this area. So now it is 3 and 4. So these 3, 4 are the members of this A intersection B. So we say that it is 3, 4 is A intersection B. Next is, the next one is, you have, suppose I take A, and let us have the points as A and B. Now I wanted the portion which is covered only here, which is covered only here, let us say. Then what is this portion? This is given by A B bar. That means what? B complement. B complement means what? The portion which is not in B. The portion which is not in B. This is denoted by A but not in B. So this is what the portion. You see, observe that the common area is not covered because common area is belonging to B. So we don't want the portion which is in B. So which is given by A B bar. So next is, now what is this A B bar elements which are in this set now? The elements which are in A but not in B. So take the elements. Now 1 is there here. 1 is in A but not in B. 2 is in A but not in B. So 3 and 4 are in A. They are in B. So the elements 1 and 2 are in A B bar. That is what you have to understand. So 1, 2 are in A B bar. Now similarly, if you want to select now the two sets again, the two sets A B. Now we wanted A B bar. Now let us say take now this portion. Now what is this portion? This is given by A bar B. Now I don't want the portion which is in A. Now the portion which is totally outside of A, that means it is in A bar B. So now according to the problem given example, the elements which are in B but not in A. See, the element which is in 3 and 4 are in A also. So 5 comma 6 are in B but not in A. So we can take these elements are the 5 comma 6 are in A bar B. So this is what meant by the set theory concepts which you can understand. And there is one more is actually is there. I will tell you that one also. And then we will enter into the next topic. So now suppose if I want to find out A, B bar, A union B whole bar, let us say. A union B whole bar means what is that? Let us take like this, and there is a universal set like this, suppose. There is a universal set like this, suppose. Then I write this as A. I write this as A and this as B, let us say. Now, A union B whole bar means the portion which is the portion which is not in, right here, the portion which is not in A union B. So that means the portion which is outside of A and B. So this is the portion which is totally outside of A and B. Okay. So this is called as A union B whole bar, and we can also write this as A bar intersection B bar. That means the complement of A intersection the complement of B is denoted by A union B the whole bar, or A bar intersection B bar. This is what about the set theory concepts. Okay. Now I am entering into the classical definition of the probability. What is the classic definition? Definition of probability. What is the classic definition of probability? So what is meant by this? Now let us see. In the experiment of the tossing of a coin, let us say the same example I will take. So in that, the sample space is what? In tossing of a coin, the tail and head, correct? Head and tail. So now when I say what is the probability of head means, we said immediately it is 50% chances are there for getting a head, 50% chances are there for getting a tail. So what is the probability of head means? It is immediately we say that 50% means 1 by 2. Again, probability of tail means 50%, again it is 1 by 2. Similarly, now from this I want to give the definition of the probability. The sample space is given by now in the tossing of a coin, let us say, sorry, in the rolling of a die, suppose it is 1, 2, 3, 4, 5, 6, let us say. Now, the probability of 1 is 1 over 6. Probability of 2 is 1 over 6. So what is this definitions? Now what are these actually? What is probability of 6 is also 1 over 6, right? So from this we have to get the definition has been obtained from all these concepts of examples itself. So what is happening is the probability of an event. That means the event, what is the event which is our favorable event, is given by number of times, number of favorable events, number of favorable events, number of occurrence of the favorable events, number of occurrence of the favorable events over total number of outcomes, or total number of events, you can say. So this is what the, so now look at the definition now. To get the example here, I wanted the head. So now in this, when tossing of a coin, when I required to get a head, suppose, then the number of times head occurs is what? 1. By the total number of outcomes is what? 2. So it is 1 over 2. Similarly, probability of getting 1 when you roll a die is given by what? Suppose now 1 is coming how many times here? The occurrence of 1 is only 1 time, correct? Similarly, the occurrence of 2 only 1 time. At same time, the occurrence of 6 is also 1 time. So what it says that probability of 1 is 1 over 6, 2 over 6, 1 over 6, probability of 2 is 1 over 6, and so on. So that means the occurrence of the event is 1 and the total number of events is equal to 6. So this is what the classic definition of the probability. I'll give you one more example to understand this. Suppose my set S is having the elements as 1, 2, 2, 3, 4, 4, 5 and 1, let us say. Now, in this, what is the probability of the occurrence of the event 2 if I ask you? Now, the number of times 2 is occurring here. How many times 2 is occurring here? Number 1 and 2. There are 2 times, correct? 2 comes 2 times in this sample space. So now, this is not like a rolling of a die or something. It's normally a set is been given, suppose. Now in this, the number 2 is appearing 2 times, so 2 over how many number of outcomes it is? 1, 2, 3, 4, 5, 6, 7 and 8. So it is 2 over 8. So that means it is 1 over 4 is the probability. And then what is the probability of getting 4 if I or 4 if I ask you? That is also how many times 4 is occurring here? Appearing here 2 times. Again over 8, it is 1 over 4. Similarly, what is the probability of occurring 5? Suppose the appearance of 5 is only 1 time. So it is 1 over 8. I hope you could understand now how to write down the definition, the number of favorable events, the events E over the total number of outcomes. That is what the classic definition. Now, what are the actual properties of this probability? Now, if you observe here, one thing that whenever we say about the probability, it is 1 by 2 or 1 by 6 or 1 by 3 or 1 by 4, 1 by 8, whatever, but it is not beyond 1. Understood? So, the major things you have to understand here is the concepts of probability is the very important thing is probability of any event is always less than or equal to 1. And can I say that there is a chance of minus 50% that tomorrow it rains? Is it a meaningful sentence? No, right? So that means what? There is no negative. It cannot be negative. It may be 0 because there is impossible event will be there, of course, right? So there is an impossible event that definitely my lecture, so many of the students are able to understand the lecture is a possible event, suppose. They are not able to understand is impossible event, suppose. Then we say that the event probability is 0. Understood? But it cannot be negative. So the event, probability of the event always lies between 0 and 1. That is the most important thing you have to understand. You have to see that this is an important thing. And then what next is, if you take the probability of the sample space, that sum of all the possibilities of the outcomes. Now you look at the example here. When you take the probability of the head is 1, probability of tail is half, so half plus half is 1, correct? Sorry, probability of head is half, probability of tail is half, so sum of these two is giving you 1. Similarly, when you add 1 over 6 plus 1 over 6 like that, 1 over 6 times, it is 6 over 6 which is equal to 1. Like that, whatever you are adding. Now, as I gave you this example as a random example, let us check now this one also. Let us see what is the probability of getting 1 here. How many ones are appearing here? 2 times. So it is 2 over 8. And how many, next 1, 2 is over, I have 3 again. How many 3's are there? 1 time. So it is 1 over 8. 4 is over, 5 is over, correct? Now these are the events I want. So let us see what is the probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5. These are the total events, correct? What is probability of 1? 1 is 2 over 8. So it is 2 over 8. Probability of 2 is 2 over 8. Probability of 3 is 1 over 8. Probability of 4 is 2 over 8. Probability of 5 is 1 over 8. Correct? So now how much it is? 2 plus 2, 4 plus 1, 5 plus 3, 8. 8 over 8 is 1. Exactly. Understood? You take any random experiment and you add all the possible outcomes like this, then definitely all of them, when you add them, it should be equal to 1. So that is what another important axiom of the probability, that probability of yes is always equal to 1. That is another important concept. And then The third one is the probability of an empty set. That means totally it is an impossible event. So that is what? 0. Impossible means that is what the possibility, the impossible event is what? Suppose if you roll a die, what is the possibility of getting 7 in rolling of a die? It is impossible, right? That is 0. Now coming to another important theorem, which is the addition theorem. Addition theorem. The addition theorem, what it says is the probability of A union B is given by probability of A plus probability of B minus probability of A intersection B. So this is what you have to understand about the addition theorem. If A and B are any two events, then P of A union B is given by P of A plus P of B minus P of A intersection B. So this is what the this one. And now if suppose I say that A and B are mutually exclusive events. If A comma B are mutually exclusive events. What do you mean by mutually exclusive events? The events, both of them are not common. That means both the events will not happen at a time. We have explained you here, right? The mutually exclusive events means what? The intersection is empty. Both of them are totally disjoint, you can say. So when you toss a coin, head and tail will not happen. When you roll a die, 1, 2, 3, 4, 5, 6, totally all these numbers will occur at a time, will not occur at a time. So like this now. So these are the mutually exclusive events I said. So when according to the addition theorem now, when I say that A and B are mutually exclusive, what is A intersection B? A intersection B is null set, correct? Now that means it is impossible event, correct? Now what is P of A intersection B? Then the probability of an impossible event is 0. In such a case, what is the probability of A union B now? You observe here in this equation, what is the equation is? P of A union B is P of A plus P of B minus P of A intersection B. When P of A intersection B is empty set, it is null set, and so P of A intersection B is 0, correct? So when A and B are mutually exclusive events, then P of A intersection B doesn't exist, right? So we say that it is the P of A plus P of B, that's it. So this is what the mutually exclusive events means. Now coming to the next one, another important result is the multiplication theorem. Addition theorem is over. Now the multiplication theorem. What is this theorem says? If you have any two events A and B, P of A intersection B, the two events must be independent. P of A multiplied by P of B when if A and B are two independent events. If A and B are independent events or independent events. That means, as I told you, when the events are independent, there is a possibility of the occurrence of A intersection B, right? Both the events may happen definitely. Then the product of them, product of their probabilities is given by P of A intersection B. So then when this happens, when A and B are the two independent events. As I told you that A is an event, let us say, A is an event who is what you can say is the student attending the probability class, and B is an event the student attending another student attending the calculus class. B is another student who is attending the calculus class, let us say. So the two events are independent. The student A attending the statistics class and the student B attending the calculus class, both are independent events, correct? And at the same time, both of them may happen, correct? So A intersection B exists, understood? So if A and B are independent events, P of A intersection B is given by the product of their probabilities. So this is about the multiplication theorem, which you have to understand. And then there is another concept of, now I will explain about the how when you do the word problems, how to interpret the set theory, the statistics and mathematics. Now let us see now in the set theory how it is expressed, and in set theory, and in probability how you will write, and then in mathematics how will you write. When in whatever the word problems, if you are given, suppose probability and this. Suppose in sets you have got union, probability of A union B something is there. Generally in words what we say is R. And when you do the calculations, then we use plus. Okay, union means sets, and R, whenever union is there, we write it as R in the probability. That means either this happen or that happen. That is what the meaning here we will write. And when you are using R, you should understand that you are adding. Now, then when suppose intersection is there, suppose, then we write this as both the things are happening, suppose. Then we say that the event A and the event B is happening, suppose. Then we say that and then we multiply. So this is what the interpretation of sets, probability and mathematics. If you remember this, then it will be easy for you to understand. For a small example I'll give you. Suppose you have gone to a canteen. So the probability of giving an order, the order of one cool drink out of, there are many cool drinks, let us say, out of 10 cool drinks, and let us have 2 sandwiches out of some 12 sandwiches, let us say. So then what happens here? One cool drink out of 10. That means now you should understand the combinations now. So for this now, the combinations is what another concept here. To make you to understand the combinations means, for example, I have 3 students in a class. Okay, I have 3 students in a class. I wanted to select 2 students. The select 2 students. How many possibilities are there for me to select 2 students? Now let us see. The possibility of selection of 2 students means out of 3 students, I can select 1, 2, correct? Or I can select 1, 3, first and third student. I can select the second and third student, correct? So these are the possibilities I have. So there are totally 3 possibilities are there, correct? Selection of 2 students out of 3 students can be done in 3 ways. That is either first and second, or first and third, or second and third. So total number of selections are what? Number of selections, what are the possible selections I have got now is 3. Number of selections is 3. So this is done by using an important formula which is given by NCR. That means what? Selection of R objects out of N objects. Then that is called as, that is denoted by NCR. Selection of R objects out of N objects is given by NCR. So now in this example, now what is the selection here? Out of 3, I wanted 2. So 3C2 value, which is equal to 3. You can see this in your calculator. There is a formula that n factorial by r factorial into n minus r factorial. All this is there. I don't want to go deep in that combinations. You can see in calculator what is that value. 3C2 is 3, and exactly we got these 3 are the selections, number of selections. So this is what about the selections means. You can see like this. So now coming to our example, I want to select 1 cool drink out of 10 and 2 sandwiches out of 12. So what is that example in this? How can I write this as means? The answer for this example, I'll just take down here. I wanted 1 cool drink out of 10 cool drinks, can be done in 10C1 ways, and I want 2